Sound is more than just what we hear. It's a physical wave moving through the air, a fascinating phenomenon that shapes our world in ways we often take for granted. Every sound, from the softest whisper to the loudest thunderclap, begins as a vibration. These vibrations set air molecules into motion, creating invisible waves that travel outward in all directions. The science of sound, or acoustics, helps us understand how these waves behave, interact, and influence our daily lives. Much like ripples in a pond, sound waves spread out from their source, carrying energy through the air. When you drop a stone into water, the ripples move away in circles. Sound does something similar, but in 3 dimensions, filling the space around us. When I speak, my vocal cords create vibrations that push air molecules, forming a chain reaction that travels to your ears. This process is happening constantly, whether we're talking, singing, or even just breathing. The air acts as a medium, carrying these vibrations until they reach someone else. Your brain then decodes these vibrations into recognizable sounds. It's an incredible feat. Your ears and brain work together to turn simple air movements into language, music, and meaning. This is how we connect, communicate, and experience the world. In large, empty spaces, clapping your hands produces not just one sound, but a series of fading echoes. The original sound bounces off distant walls and returns to you, slightly delayed, creating that familiar echo effect. These echoes are sound waves bouncing off hard surfaces, walls, floors, ceilings, blending together as reverberation. In some places, the echoes overlap so much that they create a lingering, almost musical quality to every sound. Reverberation gives each space its unique acoustic character, shaping how music and speech sound. But it also complicates precise sound measurements, making it difficult to isolate the original sound from its many reflections. For scientists, these reflections are a problem. They mask the true sound of whatever is being tested. Accurate research demands a way to eliminate these unwanted echoes and reverberations. To get pure, uncontaminated sound, researchers needed a space where echoes simply don't exist. This challenge led to a remarkable innovation in acoustic science. This led to the invention of the anechoic chamber, a room designed to absorb sound completely. Every surface is covered with special materials that trap sound waves, preventing them from bouncing back. Anechoic means without echo, and these rooms are engineered to be the quietest places on Earth. Inside, it's so silent that you can hear your own heartbeat, and even the faintest sounds become noticeable. Here, the dance of sound waves comes to a halt, allowing for the purest possible study of acoustics. Scientists and engineers can finally measure sound without interference, unlocking new discoveries about how sound truly works. Anechoic chambers are essential for anyone who needs to understand sound in its most unfiltered form. They are the ultimate tool for exploring the mysteries of acoustics, helping us design better audio equipment, quieter machines, and even more comfortable spaces for living and working. An anechoic chamber is a room that swallows sound, leaving no echoes behind. Imagine stepping into a space so quiet, it feels almost otherworldly, where your own heartbeat and breathing become the loudest things you hear. These chambers are designed to create an environment as close to absolute silence as possible, making them some of the quietest places on Earth. Its first goal: total isolation from outside noise. No traffic, no air conditioners, not even the faintest hum from the world outside can intrude. The chamber is often built deep inside buildings or surrounded by thick, heavy walls to shield it from the chaos of everyday life. Not even a whisper can get in. Every seam, every joint, and every possible gap is meticulously sealed to prevent the tiniest sound from sneaking through. The second goal is to eliminate all internal reflections. The walls, floor, and ceiling are covered with wedge-shaped foam or fiberglass that absorbs sound waves, so any sound you make simply vanishes, swallowed up before it can bounce back. Snap your fingers inside, and you'll hear one crisp snap, then nothing. There's no echo, no reverberation, just pure silence that can feel both peaceful and unsettling. The chamber creates a free-field environment, like being suspended in infinite open space, where sound behaves as if there are no boundaries at all. Achieving this requires a room within a room design, with every detail engineered to block and absorb sound. The inner chamber floats inside the outer shell, separated by air gaps and layers of insulation. Sound is persistent, traveling through air, walls, and even the ground. so every path must be sealed. Specialized materials and construction techniques are used to stop vibrations and noise from sneaking in. Building an anechoic chamber is a battle against vibration and noise in all forms. Even footsteps or distant machinery can threaten the silence, so vibration dampeners and anti-vibration mounts are essential. The result is a laboratory where scientists can control every aspect of sound. Here, they can test microphones, speakers, and even study how the human ear perceives sound without interference. With echoes and noise eliminated, they can measure, test, and innovate with unmatched precision. This level of control is crucial for developing new audio technologies and understanding the science of acoustics. It's the ultimate tool for studying sound in its purest state, a place where silence is not just heard, but truly experienced. Achieving true silence starts with blocking outside noise. In a world filled with constant sound, traffic, construction, even the hum of distant machinery, creating a truly silent space is a remarkable challenge. The first step is to shield the chamber from the relentless noise of the outside world. Anechoic chambers begin with thick, reinforced concrete walls, sometimes over a foot thick, to stop airborne sound. These massive barriers are engineered to absorb and reflect sound waves, ensuring that only the faintest vibrations might pass through. But sound is sneaky, so a second inner room is built inside the concrete shell, separated by an air gap. This room-within-a-room design is crucial, as it prevents vibrations from traveling directly through the structure. This air gap acts as a powerful insulator, draining energy from any sound that makes it through the outer wall. The gap itself is carefully calculated to maximize its sound-dampening effect, making it nearly impossible for noise to bridge the divide. The space between walls is often filled with dense, sound-absorbing materials like mineral wool or fiberglass. These materials trap and dissipate sound energy, further reducing any chance of noise intrusion. Every layer is designed to strip away more of the invading noise. Each material is chosen for its unique acoustic properties, and together, they form a multi-layered defense against the outside world. Even the door is a feat of engineering, heavy, multi-layered, and sealed airtight, like a bank vault. Special gaskets and locking mechanisms ensure that not even a whisper of sound can slip through the stauro. Maar Bernien Cyber Saws. These doors prevent any weak points in the chamber's acoustic shield. Every seam and joint is meticulously sealed, leaving no path for sound to enter. Entering an anechoic chamber means sealing yourself off from the outside world completely. Once inside, the door closes with a heavy, satisfying thud, and the outside world fades away. The result, a fortress of silence, where even the faintest external noise is kept at bay. Here, the only sounds you hear are those you bring with you. Only then can the true nature of sound inside be studied. Researchers can measure the tiniest vibrations, free from interference, and explore the limits of human hearing. This level of isolation is the foundation for all further acoustic experiments. Without it, the delicate science of sound would be drowned out by the world outside. Stopping airborne sound isn't enough. Anechoic is not enough. Vibrations can travel up from the ground. Structure-borne noise from traffic or machinery can rumble through concrete floors. The solution? Make the chamber float on massive springs or elastomeric pads. This suspension system absorbs vibrations, isolating the chamber from the building and earth. The springs are carefully calibrated to block unwanted frequencies while supporting the chamber's weight. In advanced chambers, a second shell may maintain constant temperature, ensuring sound travels predictably. The result is an island of stillness, immune to the world's shakes and rumbles. Only in this environment can the faintest sounds be measured with precision. Now, the challenge is to stop sound from bouncing inside the chamber. The solution: cover every surface with deep wedge-shaped foam or fiberglass structures. These wedges trap sound waves, forcing them to bounce and lose energy until they're absorbed. The deeper the wedges, the better they absorb even low-frequency sounds. The floor is a suspended mesh, letting sound pass through to be absorbed below. Walking inside feels surreal, like floating above a sea of spikes in total silence. This design creates a space where echoes simply can't exist. It's the ultimate environment for pure, unreflected sound. Why build such a silent room? Anechoic chambers are vital for science and industry. Researchers study human hearing here, isolating how we locate sounds in space, crucial for hearing aids and 3D audio. Companies test products like cars and appliances, measuring noise levels to make them quieter. Semi-anechoic rooms, with solid floors, simulate real-world conditions for larger items. Audio engineers use these chambers to perfect microphones and speakers, ensuring accurate sound reproduction. Material scientists test how well new panels block sound, helping design quieter buildings and vehicles. Every measurement is pure, uncontaminated by echoes or background noise. The data gathered here shapes everything from consumer electronics to architecture. Anechoic chambers are the silent backbone of innovation in sound. They make our world quieter, clearer, and more comfortable. Traditional anechoic chambers struggle with very low-frequency sounds, those deep rumbles with long wavelengths. Foam wedges can't absorb these, so some low-frequency echoes remain. The new solution: active acoustic control. Microphones and speakers line the walls, detecting and instantly canceling low-frequency waves with anti-noise. A computer analyzes incoming sound and generates a mirror image wave, erasing the echo through destructive interference. This real-time system creates silence even for the lowest rumbles. Hybrid chambers now combine passive and active methods, covering the full range of human hearing. This breakthrough opens new frontiers for acoustic research, without building ever larger rooms. Stepping into an anechoic chamber is a disorienting experience. The silence is so deep, you can hear your own heartbeat, blood flow, and even the faint hiss of your nervous system. Some find it fascinating, others feel unsettled by the lack of external sound. It's not dangerous, but the absence of echoes can make you feel off balance. Your voice sounds flat and dead, forcing you to speak louder. This profound quiet strips away the world's noise, revealing how much our brains rely on echoes. It's a powerful reminder of the invisible role sound plays in our perception. In this space, you experience sound and silence like never before. Anechoic chambers are more than just quiet rooms. They're precision tools for science and innovation. They let us break sound down to its basics, driving advances in medicine, engineering, and technology. Research here leads to better hearing aids, quieter cities, and clearer communication. By removing noise and echoes, these rooms enable pure, repeatable experiments that push the boundaries of knowledge. They help set standards for noise pollution and inspire quieter, more comfortable products. In their silence, anechoic chambers reveal the true nature of sound and our relationship to it. Whether passively absorbing echoes or actively canceling them, these rooms are vital to progress. In the quest for quiet, we discover the secrets of sound and shape a better world.